I'll have highlighters. All right. It really does not matter which color is which. First thing I'm going to point out, and I don't know how dark it is on your papers, but I want you to be aware there is this zigzag line on the periodic table, and we're going to be coloring on either side of that zigzag line. So I'm going to pick whatever colors you want to pick. I'm going to do non-metals first. So just color in your key, whatever color you want non-metals to be. This doesn't have to be the most artistic thing ever. You can just do an outline if you want, or you can color the whole thing in. It's up to you. Non-metals are to the right of the zigzag line. So I want you to color to the right of the zigzag line. Color that in this non-metal color. But, and I want to make sure that you guys get this and you don't miss it, hydrogen is a non-metal as well. It's an exception to the rule. It's kind of on the, in terms of metals and non-metals, it's kind of on the wrong side of the periodic table. So make sure, I'll give you a second to color that in. Make sure that you get hydrogen and then all of the elements that are to the right of that zigzag line colored in that same color. When you are ready, your other color is going to be for the metals. And really, the metals is everything else on the periodic table. So metals are to the left of the zigzag line. I'm not doing the best job ever. It's my 4th time coloring in this periodic table up on the board. So a big part of this unit is going to be identifying the differences between metals and non-metals, or identifying elements as metals or non-metals. Activity number 1, we're going to go back to the fume hood. I'm going to do a demo with, it says, adds a chunk of solid sodium to the beaker of water. Just to kind of practice, sodium is right here. Its symbol is Na. Would sodium be a metal or a non-metal? A metal. So it's to the left of the zigzag line. So that makes sodium a metal. So the demo is just putting a piece of metal in water. Shouldn't be a big deal, right? You can. All right. So sodium is a really, really neat metal. It's so soft that I can just kind of pull it out of this container just like by stabbing it with a lab scoop. Okay. And it's so soft that I can cut it with just a lab scoop. And it's like really easy to cut. So I'm going to show you what it looks like. Almost kind of just to prove that it's a metal, because normally putting a metal in water would not be that big of a deal. So it's just kind of this shiny, silvery color. Okay. I'm going to clean off a little bit of this liquid and then put it in water, close the fume hood, and we'll see what happens. That was a really good one. What I want you guys to do, if you haven't started yet, you guys write your observations. What did you see? What did you hear? What did you notice? Anything that you can think of here. And then once you guys are finished writing that, then I'll kind of talk to you about an explanation. All right, so explanation here. When that sodium hits the water, it rapidly forms, or I'm going to say rapidly releases, hydrogen gas and heat. I've done a demo in this class with hydrogen gas before. What do you know about hydrogen gas? Remember the very first day of school demo, the Hindenburg. What do you know about hydrogen gas? Yes, it floats. That's why it was used for the Hindenburg, but it's also extremely flammable. So what happens is it releases hydrogen gas very, very rapidly. So it doesn't really have time to like spread out all throughout the fume hood. It's forming that hydrogen gas all at once, kind of right on the top of that beaker. And then it also produces a lot of heat, and that heat is enough to ignite the hydrogen gas. And it then, as you saw, explodes. So what I want you guys to do, there's 2 questions for you to answer. For the first one, give me a thumbs up or thumbs down. Is sodium a reactive element or a non-reactive element? Thumbs up for reactive, thumbs down for non-reactive. Oh, come on. It's pretty reactive, and I'm going to say it's going to go along. That's why sodium is our first deadly element. Okay? Question number 2, you can't see it up here on the board, but it's asking you whether it was a physical or chemical change. I want you to think about if it's a physical change, it's the same substance. If it's a chemical change, there was a new substance being formed. So make sure you choose chemical or physical, but then also explain why you think that.
Okay, so hopefully you guys have the 2 questions for sodium answered. We're going to now take a couple minutes, like 2 minutes, read these 2 paragraphs about chlorine gas, and then we will come back and talk about this and answer the questions that go with this. Okay, so before we look at these questions, do any of you have a swimming pool? Yeah? What's the chemical you put in your swimming pool to keep it clean? Chlorine. When you get in the swimming pool and you open your eyes underwater, do your eyes burn after a while? No? Of course, Ben's don't. But for most of us, if you open your eyes underwater in a swimming pool that is chlorinated, it will start to burn your eyes. The chlorine we put in our pool is oftentimes in tab form. And during World War I, it was the first time that chlorine gas was actually used as a weapon of warfare. And the Germans were the first to use it. Chlorine gas is the concentration of chlorine gas is so much stronger than the tablets we put in our pool. So the tablets that go in our pool and they burn your eyes, chlorine gas will intensify that sensation. But with gases, you obviously breathe them in. So chlorine, if you breathe in the gas, it will literally burn your lungs and your throat and esophagus from the inside out. Mustard gas was also used during World War I. It does not come from mustard. Let's just put that out there. It was called mustard gas because it was a yellowish color. Same thing. It would burn you from the inside. It would burn through your tissues. It would burn through your skin. So you would not only burn from the inside with mustard gas, it would also burn you on the outside and cause lesions on your body. So chlorine is also very, very poisonous to us. Do you have a question? No? Okay. So you guys read these 2 paragraphs here about chlorine gas in World War I. Now this first question is asking about the advantages of using chlorine. Don't think about it as far as what are the advantages of using it as a weapon, but why was chlorine used as a weapon? What made it easier to use that as a weapon than something else maybe? Do we have any ideas? Go ahead, Jacob.
It was heavier than air, so it wouldn't just trenches.
Okay, could be. Look deeper into the second paragraph. Ben, go ahead.
It's easy to obtain.
Easy to what?
Obtain.
Yeah, chlorine is easy to produce, easy to manufacture, but it's also easy to compress, so you can store it in small containers and transport it easily. So that's why chlorine was one of the reasons why chlorine was used so much in World War I. Just an FYI, today there are rules of war, and chemical warfare is illegal. Rules of war. Super cool. Okay, how did soldiers protect themselves? Jacob?
Gas masks.
Gas masks. They would sometimes take cloths and soak them in liquids and put them over their mouth and nose. Unfortunately, with gases and the way the trench warfare happened, when the gases would settle into the trenches, they wouldn't go away. They would stay there. So you could be, a couple weeks after a chlorine gas bomb went off, and you could still be getting the effects of that chlorine because it just like lingers in the trenches. It's gross. What are disadvantages of using chlorine gas as weapons? Did anybody think of any of those? Owen?
You wouldn't be able to go in right after the other story.
Say that again?
Like, if you did that to a knife, your soldiers wouldn't be able to.
Oh, okay. Yeah, does anybody want to piggyback off that? What can move gases?
Yeah, so we're just thinking,
Jacob?
like, wind over in yours.
Yeah, and this happened quite a bit during World War One, where let's say the Germans would drop a chlorine gas bomb, and then it would get windy, and it would blow the gas back onto their own soldiers, the German soldiers. So using gases can be very unpredictable because they're very hard to contain and control. So number 4, then we need to predict whether you think chlorine is reactive based off of the fact that it can burn human tissues from the inside out. It will burn through your lungs. It will burn through your throat. Yeah. Yeah, go ahead and answer that. Yes, it is reactive. It is going to be harmful. What's also kind of tricky about chlorine is like it can kill you very quickly, or it could like take forever, and you would just like burn. Okay, let's take a look here at the summary then. So we have the reaction when we take metal, sodium, and we take chlorine gas, and we add it together, we end up with sodium chloride. You all know this as simple table salt. So if we cannot eat sodium on its own, we cannot eat chlorine, ingest it, breathe it on its own. But when we combine it, bond it, we now can eat it as salt. How would you explain that? I guess I kind of just did, yeah? So you can take 2 deadly elements that on their own would be deadly to us to eat, and when you bond them together, we're going to end up with something totally different. We're going to end up with salt. So now we can now eat salt. So technically we're eating deadly elements, but because they're bonded, they're no longer deadly. So for number 1, so you're citing your piece of evidence, we're ending up with something different. We're ending up with salt, which changes its properties, and now salt is no longer deadly to us. So after you get something to that effect written down for number 1, think about any other labs that we have done, and think about when we have 2 things that we bond together, they end up with something different.
Really, any chemical change that you've seen in this lab. It could be from copper cycle, from the fireworks lab, from physical chemical changes. Any chemical change that we've seen, you could use to explain this. Because anytime you form a compound or a new substance, that new substance has different properties.
Okay, guys, just to finish up here, this last activity, you guys have a couple steps you're going to be doing here. First of all, you're going to be identifying each of our elements as a metal or non-metal. So use your periodic table on the wall, use your periodic table on the front of your packet there, and just do follow the example for letter A and label non-metal or metal. And then remembering your rules for what is an element, what is a compound, and what is a mixture. go ahead and put your 9 samples under element, compound, or mixture. And then finally, you're going to divide them again into categories of substances made up entirely of metals, substances made up entirely of nonmetals, and substances made up of both metals and nonmetals. Okay. If you have any questions, please ask, but we want to make sure we check this before you finish